All right, so in problem 29, we got 153 deer taken by Yunners, find 32 of them carrying ticks. So we got to create a 90% confidence interval in A. If we want to cut the margin of error in half, how many deer must they inspect? And then what concerns do we have? Okay, so let's look at this. So we're going to go through it. So P, our parameter here is a proportion of deer that have ticks, right? Okay. The assumptions. This sample should be representative. The deer, the ticks could be independent. We're going to have to assume that they could be, because the problem is ticks travel from one animal to another. So, and deer tend to run in packs. So there could be an issue with independence. That's why I put could be there. 153 is less than 10% of all deer. And then it said that 32 of them. So NP is 32. That's at least 10. And then 153 minus 32 is 121. That's also at least 10. So our conditions are met. Name it. This is a one prop confidence interval. P hat in this case is going to be 32 out of 153. So that's, I'm just going to say it's about 0.21. Q hat is about 0.79 and N is 153. The interval itself, P hat, 0.21, plus or minus, we're doing a 90% confidence interval. Square root of P hat, Q hat over N. When we do the interval, we get about 15.5 to 0.263. We do it in our calculator at that point. So conclusion, we are 90% confident that between 15.5% and 26.3% of all deer have ticks. Okay, so that's our conclusion. The second question is we want to cut the margin of error in half. Okay. So if we want to cut the margin of error in half, then what must we do? Okay, well, I think we've talked about this in class. If we want to cut the margin of error in half, so if we want, let's say, well, I guess we could figure this out in this case. If we did 1.645 times the square root of 0.21 times 0.79 divided by 153, and we get 0.054, right? So the margin of error here is 0.054. And I got that from just using this right here. Well, if I cut that in half, I get 0.027. So I could do 0.027 equals 1.645 times the square root of 0.21 times 0.79 over n. And if we do that out, then let's see, we wind up with okay. Yeah, we wind up with about 608, right? Well, how many times large? The original sample was 153, and now we're going to 608. So if I do 608 divided by 153, now this is going to be an estimate. But guess what? You get about 4 times as large. Now we talked about that in class. If we want the sample size, if we want the margin of error to get cut in half, then because we're dealing with a square root, we got to multiply n by 4. And that'll come out, the square root of 4 comes out as a 2 on the bottom, and then our margin of error is half as large. Now the last question is, what issues do you have with this problem? The problem is with independence. Okay, I don't know if you know too much about deer, but deer run in packs. So the fact that one deer having ticks may not be independent of another deer having ticks. So it is possible that one deer having ticks, if it runs with another deer, the probability that the other deer will get ticks goes up, because think of it as a contagious kind of deal. Okay, so that is a possibility.